Hello, welcome back. So what we're going to talk about today is it says about the slope of a line. So our goals then are going to be from this different discussion is find out be able to find the slope of a line of the graph and graph a line using the slope. And then also understand what the slope of a line tells you. So let's take a look. So a slope, here's the definition of a slope, we'll see. And to explain it, let's come over here to the right. Well, let's just draw a line. So let's just draw a really basic set of axes. We'll do this the first quadrant to make it simple. Let's say this is our line. Okay. Now, basically, any line can have any kind of graph can have a slope, but here we're talking about a graph of a straight line, of the slope of a straight line. So the slope of a straight line is basically what's called rise over run. Okay. So basically, for whatever distance you're going horizontally, it's how fast you're changing or how much you're changing vertically, whether going up or down. So you notice here's the definition of a slope: y2 minus y1 over x2 minus x1. So let's see where this definition comes from. So let's imagine we have 2 points on this line. This is the point we call x1, y1. And this is our point. We'll just call it x2, y2. Okay. Now, what you can do is we can make an imaginary triangle, a right triangle here. And down here, let's put our coordinates. So this is our x1. This is our x2. And this is our y1. And this is our y2. Now, we think about this change. So the change we're going in x from here to there is this distance, which we can write as x2 minus x1. Okay. So imagine if to say this was 5, this was 3, that distance would be 2, right? You get that because it's 5 minus 3, which is 2. Of course, this is our change in x. And this distance here, the same way, is y2 minus y1. That's our change in y. Okay. So then our slope then is change in y for a given change in x or for a certain change in x. So we fix our distance we're going horizontally. Then this tells you how far up or down you go. Our slope a line could be going up, it could also be going down, or it could also be flat or vertical. We'll talk about those in a moment. Okay, that's where it comes from. So it's the change in y over the change in x. Also, it's called the rise over the run. This is your run. This is your rise. Okay, now notice here it says for our formula, so for x2, x1 not equal to x2. We'll talk in a moment why that's the case. Now, here's some things to point out about the slope. We have the slope of a few lines here below. So 2 points are needed to define a line. Okay. Next, the slope gives the rate of change of y with respect to x. And for a straight line, this rate of change is constant. Okay. For a straight line, that slope never changes. A positive slope means it says the line is going up from left to right. So this, for example, this line has a positive slope. So basically, you see, if you think about a positive change in x, a positive run, our rise is positive. So that means our line is going up from left to right. A negative slope, then, as you might expect, means the line is going down from left to right. Okay. Now, we can also have a slope of 0. That means we have a horizontal line. We can also have an undefined slope. That means we have a vertical line. Okay. Also, if lines are parallel, parallel means lines never touch, they have the same slope. And for that to be true, it means they have to be parallel. And also the slopes of perpendicular lines are negative reciprocals of each other. Now, so let's talk about let's do a few examples of how we can actually find the slope of the line, given 2 points. So find the slope of the line that goes through the points. Let's look at our first example. Okay, so number one, let's say we have these 2 points. So we have points 2, -3, and -7, 1. Let's say these 2 points are on a line. Okay, now also let me graph this line. We'll actually graph the line. This is on. So let me actually add a grid here, and we'll do this below. So let's graph both these. So 2, -3. Point 2, -3 is right here. And -7, 1 is right here. Okay. So you have a line. If you think about a line that goes through those 2 points, looks something like this. Okay. Now, what we've learned so far, this line is going down from left to right. So then we have a negative slope. So we should see that when we graph, we actually find the slope. So let's do that. Okay. Now, what I'm going to do is I'm going to call this point our x1, y1, and this our x2, y2, though it doesn't matter as long as you're consistent. Okay. Also, slope is sometimes called the letter m. We'll see that when we talk about the equation. So the slope is equal to m is going to be, if we follow our formula, y2 minus y1. So this y minus this y. So be careful with your sign. So y2 is 1 minus, this minus is part of the formula, then -3, okay, minus that y. Then this x, which is -7, minus, this minus is part of the formula, then this, or x1, which is 2, then we simplify, okay? So this will become 1 plus 3. This will become -9, and so we have 4/9. Or sorry, -4/9. We bring the negative out front. Sorry, let me clean that up a bit. So we can bring the negative out front, and then our result is 4/9. And of course, you want to reduce your fractions if you can. Okay. So this tells us the slope of this line is a slope of -4/9. Also, one thing I didn't mention is that the absolute value of this slope tells you how steep it is. So the larger it is in absolute value, the steeper the slope is. The steeper the line is, the larger the slope is in absolute value, either positive or negative. Now, let's take a look at the same one again. And I can squeeze this in here. Let's imagine if instead I did it the other way. So let's say I was going to rewrite my points again. 2, -3, and the other point is -7, 1. This time, what if I call this one x2, y2, and this one x1, y1? Let's convince ourselves we get the same result. So m, slope, is equal to y2 minus y1. So y2 is -3 minus, this minus is part of the formula, then y1, which is 1. And down here, I have x2, which is 2, minus is part of the formula, a -7. So if we simplify that, the top is -4. Down here, we have 2 plus 7, which is -4/9. Exactly the same thing. Now, the one thing you have to do is once you choose whichever point you want to call x1, y1, or x2 to y2, be consistent. So whatever y you start with at the top, start with this x down here. Okay. So in this case, we started with this 3 here. We have to start with its x, corresponding x here. If we don't, we'll get the wrong sign. Okay. So that's how we find the slope. Okay. Now, so that was a negative slope. Now let's take a look at a couple more examples. Number 2. And also I'm going to create another graph here. So let's say this time, number 2, my 2 points I want to look at are 2, -1, and 5, -1. Okay, let's graph both those. So 2, -1 is right here. 5, -1 is, oops, I'm sorry, that's not right. I looked at the wrong point. So 2, -1 is right here, and 5, -1 is right here. Now, if I draw that line, I think you can see that's actually appears to be a horizontal line. Okay. Now, what I said over here is that a horizontal line or a slope of 0 means the line is horizontal. Okay, we have horizontal line, so we should expect a negative slope. Let's make sure that happens. So I'll call this one x1, y1, this one x2, y2. Then my slope m is going to be this y minus this y, so -1 minus a -1. If I start with this y, I start with this x, 5 minus 2. And then I have -1 plus 1 over 3. 5 minus 2 is 3. And of course, now I have 0 over 3, which is 0. So the slope is 0. So once again, that implies this is a horizontal line. Okay, so a horizontal line has a 0 slope. So in terms of rise over run, there's run, there's no rise. It's flat. Okay, let's look at the next one. So this time, my 2 points are going to be 3, 5, and 3, 9. So once again, let me include a rectangular coordinate system where we can graph it. And once again, let me call this one our x1, y1, x2, y2. Let's also graph these points. So 3, 5 is right here. And 3, 9 is right there. So this appears to be a vertical line. Okay. So in a vertical line, it's vertical. In terms of rise over run, appears there should be a rise, right? But no run, no back and forth. Let's see if that is the case. So expect this to be an undefined slope. Okay, so let's find the slope. So we do x2 minus x1, so 9 minus 5. Sorry, y2 minus y1. Then we do x2 minus x1, or 3 minus 3. So my numerator is 4, but my denominator is 0. Remember, that's undefined. So remember, anytime you divide by 0, that's what's called undefined. So this is a vertical line. Okay. And once again, I didn't draw that perfectly well. We get the idea. So the vertical line goes straight up. So there's rise up and down, no run, no back and forth. That's how you can identify when you have a regular slope or a regular line or a vertical and horizontal line. Now, let me mention, let's briefly talk about graphing using the slope. So let's do a couple examples of that. So much space I have here. So number one, let's say we want to graph this line with a slope. So a point on the line. How about we do a simple one? Let's do 0, 1, and our slope m is going to be 2. Okay. Now, let's see if I can also put another grid here. I may not have enough room. If not, I'll go to the next page. Yeah, I think I may have to go to the next page to graph this one. Let's do that. I'll show how this works. So let's find this point on the line. So the point is 0, 1. So there's our point 0, 1. Now, my slope, in fact, let me actually change this, make something a little more dramatic. Let's make this, let's make it 3 instead. I think it might be a little easier to see it this way. Okay, now how we can graph use the slope is our slope is 3, which I can think of then as being 3. M is 3. I can also write that as 3 over 1, right? So once again, I have this term of rise over run. So my run, I think this being is 1. So my run, I go 1 over here. That's 1. Okay. Then since this is positive, I go up 3 from here. Okay. So from here I go up 3. That's 1, that's 3. That gives me the next point on my graph. That point is 1, 4. Okay. Now I have 2 points. As I said before, all I need to graph are 2 points on a line. And so I can draw the line that goes through both those points. And that is the graph of my line. Okay. So I'm able to graph using the slopes. So start at any point. Then we do our run first, our x. And also if there's negative, we put the negative with the top. So it just tells us if whether we're going up or down the next point. So always think about going to the right. It's not a rule, but makes it easier. So if you have a negative, or your sign goes with your top number, goes with your rise. Okay, so go to the right this many units, then go either up or down, depending on whether this is positive or negative. Go up or down that many units from that point there, and that will give you the next point on your line. Let's do one more of those. So number 2, let's say we have the point on the line is, how about I choose -1, 2, and here my slope, let's say it's going to be negative 4/3. Okay, so once again, let me include an axis where I can graph. Let's see what this looks like. So I find my point, -1, 2. Okay, now, once again, I think of going to the right. So my run is 3. So I go 3 spaces here, 3 blocks. Okay, that's 3 at this point. Now from here, I use my negative here. Negative goes with the top number. So then I go down 2 units. Sorry, go down 4. Okay, to right here. So when it crossed 3, I went down 4. And now this is the next point on my line, which is the point -2, -2. Once again, I have 2 points, which are all I need for a line. And now that is the graph of my line. So that's briefly a bit about the slope, what it means, and then also how to graph using how to find the slope, what types of slopes we have, either positive, negative. Also, we covered horizontal lines and vertical lines, their slopes, and also we would use the slope to graph a line. Thank you. Have a good day.